Alright, welcome to another coding session on the chess engine in C. And if you remember from the previous videos, we were able to implement human movement, or I guess being able to take input from the player and make moves. And we implemented moves such as end peasant, which my favorite move, taking the pawn when it moves to squares. Then we also implemented things like being able to promote to different pieces, and we can choose a queen, for instance. And another important thing we have done, let's make a random move, is being able to see that it doesn't matter that it's losing a queen or something, but you are able to see that you can checkmate your opponent, and you get this pop-up message when you win. Yeah, so I guess the only thing that I would consider a bit scuffed right now is that the player movement is kind of hard-coded into the, let's see, game.c file. And I would say it's kind of hard-coded into this tick function, right? So we check for mouse press, we still show a promotion thingy and checkmate printing, but because those are fine. But what we do here is we check for mouse click to make a move. Okay, so that would be that. And what I would like to change in here is be able to have something like a plug and play, like a plugin here, and instead of taking input from the user, maybe we want to make random moves, like our initial chessboard is going to be random moves, right? And maybe we can have different things as well, like more advanced bots. But yeah, like we still want to clear the background, print the chessboard, probably print the checkmate message. I don't know about chess promotion, maybe that's just if you are a human player, but definitely clicking the mouse is just for human players, so this should go out from here. And if you remember from the connect4 project, you might recall that we did something similar in this game.c file, where I guess in the main file it's maybe better. We had these arguments that were pointing to DLL files, right? But what I would like to change compared to the connect4 project is that here I would like to also make it available for WASM. So how would that work, right? Like for the C project, for the Relib one, it kind of makes sense. We are going to let the user, let's say, choose between two options like we did here with two arguments, paths to the DLL. But for the WASM project, it won't work, because if we compile to a DLL, that's basically compiling to like Linux or Windows or whatever. You compile to a specific platform. So we will have to compile to WASM and load the specific WASM maybe from the URL. Maybe we'll have something like here. You can have query like player 1 is going to be human, and then end player 2 is going to be AI, or I guess random, I don't know, making random moves. And using those two strings, we will know which WASM file to load at runtime. So that's my idea of what we should try to achieve today. Maybe, this would be for the WASM project, and for the C project, we are going to load them the same way as we did with connect4. So let's go to the main file. And let's try to add these arguments here. So I'm just going to add player 1 and player 2. Those are the two players of the game. And then inside of parse arguments, let's add these two arguments. So it's gonna be player 1 and player 2. Just copy pasting the strategy for player 1, a path to the DLL, the strategy for player 2, again a path to a different DLL, right? And then we are just going to read these values. And obviously, if the subcommand is going to be count positions, then we don't have player 1 and player 2 because it doesn't make sense. But if the subcommand is game, we are going to expect player 1 and player 2. So yeah, because of that, I guess required should be false. Right? And here I guess you can see that my argument parser is not perfect because it doesn't really work with subcommands, right? We don't have sub parsers and stuff like that, so we just have to pretend that yeah, someone is going to use the help flag to get how to use it. But anyway, so let's copy paste this function as well, load move function, right? And this stuff is gonna be kind of relevant, I guess, for the game.h file. So let's go into game.h at this point, and here we need to define two functions, move player 1 and move player 2, the same way we had here. So in here it worked to just put them in the main file because we didn't have that much code, but we need something like this, right? Move player 1 and move player 2 as two separate functions. I'm curious if it's gonna work with WASM. Like they have to be variables, kind of, if I think about it. Or maybe we want some kind of init function that takes two pointers. But yeah, like an init function that takes two pointers, that's kind of not great. So let's see if it's gonna work to override these variables from WASM. Not sure though. I don't well, another option would be that in case we are using WASM, we define them as external functions, and if we are using Linux, we define them as variables. So I guess that's also an idea. Let me just double check inside of game.c. So in here you can see we have this, if it's WASM, then we do something. If it's not WASM, we do something else. So maybe I want to do something similar here. And if we are using Linux, we define them as variables. But if we use WASM, we have to define them as external functions. So extern, and we have to figure out what we want this function to be like. Let's go back to here. I guess here I was type defing the move t function. So obviously move t should be the same for both of them. So if we go to game.c, I guess the move function should return. Interesting. It should give me just the square, I guess. Just the square, but at the same time, I think that since it's like if you click on the mouse, right, you don't always get a move, so we kind of have to wait for that. Right, so here it was working because it was blocking on that, but here it's not necessarily blocking. So inside of the tick function, we need to check if we actually get a move, because maybe we don't get a move. Okay. It's also the chess promote thingy. But you know, I wouldn't want, like, I want most of the logic to be here, because otherwise if I do anything besides the move inside of that DLL, maybe you can just move randomly on the board, so you don't want that. You want the move to be valid. So maybe you need to get a list of all the possible moves and you just return an index or something like that. So yeah, maybe that's an idea, right? Maybe we pass a list with all the moves you can make into that function, and then your job is to choose one of them. Something like that. Let's see here, for instance, if you have a move that's like promote, it's a bit weird because we need another flag maybe for each kind of promote. Maybe you, because you know you can promote to queen, rook, and so on. Maybe we need different promote flags as well. But nonetheless, I think the easiest way to do it is by passing a list of moves and then you return an index. And a move is basically a char, right? Interesting. So a list of moves. That's it's kind of interesting. Because yeah, again, I wouldn't would be kind of weird to have to call give me all the valid moves in the DLL itself. I would like it to be this thing to happen before. So you get the list of all the possible moves you can make, and yeah. Or maybe, I don't know, it's something like it returns the piece that it wants to move and the index of the move. But then, I mean, you have to validate stuff like that. I think that's still the best way to do it. getting the list of all the possible moves, and getting back some kind of index for that move. Okay. So right, and then keeping the click and stuff like that as the like maybe we can have a really simple version first, like a proof of concept to check that it works. So yeah, let me think for a second. Well, I mean, for now, let's just pretend that we allow cheating, and maybe we just get the current state of the board as an input, right? So maybe what we want to have as the input for those functions is the state of the board, and then we'll try to figure out how we can improve that. Maybe we can do it like that. So we'll have a pointer to state t, and the output is gonna be modifying this thing, I guess, and the output of the function is gonna be void. So this is gonna be move t. Okay, and we need to include chess.h into here so we can have access to chess state. And in case we are using WASM, we'll have move player 1 is chess state t pointer board, and the other one as well. So that's how we are going to do this. In case we are using the WASM version, we are expecting 2 external functions, and if we are using DLLs or Linux, we want to have these as some kind of variables. But yeah, I don't know about this, because here it looks like it's complaining about how you define variables in header files. But not really sure how I can do this one easily, unless I have some kind of variables. Unless we can just have another function, like in case we just call init with these things, but I don't know. Yeah, like maybe that's another plan. Having to call init with pointer to functions. Sure. I guess that could also work. So then we just define this thing there. On the else case, we don't have anything, and maybe we just put here something like move t pointer, move player 1, move t pointer, move player 2. Maybe this is a bit cleaner, let's say. Alright, so that's how we initialize this thing. And then in game.c, it's obviously going to complain about it. Right. So what we can do now is move the pointer, move player. Two. Maybe I just use capitals. Okay. So then we can just move player one is equal to move player one. It's something like this, maybe. And then in main.c, we can have here arguments t, load move function, and to be able to use load and whatnot, we need DL function. Okay, and we might have to define these as globals. So that way we could load these functions. Okay. So if it's subcommand, maybe we want to pass in the args just arguments the args. That way load move function args, this thing should return what? Oh, it shouldn't really return anything, but we can just pass here move player one, move player two. What? So that's that. It's already a pointer, I guess, so I don't need to make it pointer. Interesting. So here it should just be like this, and then move player one and move player two can already be just like that. And then inside of game.h, we don't need the stars there. Okay. Okay, and now main actually expects this to move player one and move player two. Okay, so if it's not equal to 0, we just return 1, which is an error. Wait. Yeah, it's 1, it's fine. Okay. So we need now these move player 1 and move player 2. In here we are passing them as SOs. Okay, interesting. So we need to implement, I think in the Connect 4 project I called it player. Let's call it human.c. So what is human.c going to need? I guess it's gonna need this kind of stuff. What is that there? Let me just put them like this. So basically, if we have WASM, we want list allocator. If we don't have WASM, we want argument parser. That's easy. And inside of game.c, I don't need this part, but I need this part. Okay. So let's go to human.c, Pretty sure we are gonna need something like this. Okay. And we need this move function. So if we check again in main, pretty sure it's called connect for move. Let's call it chess move. Chess move, and it's gonna be a move t function. Okay, perfect. Oops. So let's go to move t. Let's copy paste it. Let's go to human. So we need this kind of function. Let's have chess move, chess state t pointer board, and in here we can implement our chess move. Okay, so in game.c we can just try to copy paste this kind of stuff. Right, that's what I would like to have. That's something that I would like to have. Promotion GUI, checkmate GUI. That's interesting. So now the vector to pixel, that makes sense. We don't need game.h. Promotion GUI. Like, yeah, sure, we could also just try to get a move and return like the start point and end point and then validate that that's a good move. We could also do that. Yeah. But obviously we also need this kind of promotion GUI and checkmate GUI. Because if it's like, it's important for the player to know if it's a promotion GUI, that if the promotion GUI is active or not. But for an AI, does that matter? I don't think so. So I think the promotion GUI stuff should be only for a player. So we can just copy paste this here. So we need this chess sprint promotion in the player thingy. So screen width, screen height, those things, these should be in game.h, max capacity and so on. I think these should be in game.h. So if we go back to human.c, include in game.h, because we need those. Okay. Here it's promotion square. Promotion square, I think it was a variable. But I'm pretty sure that promotion square was used just for the GUI drawing. So if we go back to game.c, we might be able to just copy paste this this here. I'm pretty sure promotion square was used just for being able to draw stuff. Okay. So here we have options. This one, interesting. Again, it's kind of just for it's kind of just for drawing purposes. mostly. Current player is a good one. Current player comes from the state, I'm pretty sure. We have current player. We don't have current player. We should have current player in here in the state. So current player, I would say, obviously we need the state here. I'd say this one, let's say it's a const. We just tell ourselves that we want to change it. But I think current player should come from the state. What? Chess piece texture path. Interesting function. Chess piece texture path. This one. Huh. It looks like this one shouldn't be a static function, and we should have it available. Chess piece texture path. Because we need it. We kind of need it here as well. So let's just have it like that. Okay, let's go back to our human. What does this want? Load texture cached. Cached. I think this one is also a static function. But again, I think this one also needs to be, for now, we'll find a better place for it, but for now, let's just keep it like this. Interesting. So game.c, let's move this thing inside of game. So we want a reliable WASM for this thing. Okay, let's go back to human.c. So now we should be able to do that. What do you mean? This is the state. Sure, we don't have current player, but as I said, we should add here current player. Current player is a character. Current player. Let's keep some space. Okay, so we have current player here. Nice. Now this is just for drawing again. Okay, then we have if promotion GUI. So maybe we want to take this promotion GUI and move it into here. So if we want to show the promotion GUI, this could also be on the state. Shouldn't really matter. Again, it should be just a human player thingy, the promotion GUI. So maybe I can keep it as a global variable here. We'll see. If it doesn't work, it doesn't work. It is what it is. Okay, checkmate GUI. This one is interesting. Not sure yet how to deal with it. Game.c px to square. Interesting. We need these functions in game.h. We'll see. Like these ones are like math stuff, so maybe we can have a math module, but I don't know. Let's go back to human. So we convert that to a square. Here we need state current player, state board. is selected. Again, I think is selected is something to do just with the human player. So I'll just move it here. Is selected. Selected square, again, it's something that's used just for the human player. Moves sounds like something I would use just here. Here we have the state. Here we apply a move, then state current player becomes state current player. State. And now this one is interesting. If we are in checkmate, then I think it's not necessarily player related, so I don't know. Pixel to option. This one is something px to option. It's something that's useful just for the player. Well, I don't really care about this one in any other place. So here it's state current player, state current player, state current player. Okay, so this one, these two with checkmate should maybe happen just on the game tick itself. So here maybe I want to do it here or something like that. But here state is like that. And then maybe we can just delete this entire thing. All right. The only part that sucks is that it's checking every time. But then I could do something like current player is equal to chess white. We do move player 1 and we pass the state. Else it's move player 2 and we pass the state. And for now I would say it's fine like this, but we have to try to like validate stuff better. Let's just leave it like that. Let's just not care that much about that. And maybe on the else here, I'm gonna do this. So we check for checkmate. Okay, so maybe something like this should be okay. Let's try to run make just to build that. And then if we go to make file, let's try to build the SO files as well. So let's compile lib human.so, lib human, and if we just copy paste this part, and we have here lib human so. So lib human so, that's gonna be interesting. Human.c, because it wants chess.h and game.h. Human.o, I think we need chess.o and game.o, sadly. But as I said, I want to kind of not depend on game, if that's gonna be possible somehow. Maybe we cannot really, like, maybe we have to depend on it because of these, but we'll see. So that's gonna be that, and we need to compile human.o. So human.o obviously comes from human.c, and you know, that's the annoying part. Now we have to check all the ds, like the h files, right? So this one needs chess.h, and it also depends on game.h, right? Like if these two files change, we have to also recompile. That's the idea. I think that's fine, but it also depends on arraylib. So I think we need to add arraylib somewhere here. So larraylib just at this stage, maybe here. So if I rerun make, it somehow fails. Multiple definitions of selected square. Because we don't need moves and selected square, and yeah. Sucks to suck, we need moves. No, but again, we don't need to do them here, we need to do them in, like we need to show the moves just for human. So I can just do it here, for instance. I need cell width and cell height, but that's just simple to have. Let's just keep it here for now, it doesn't really matter. So do we still use moves? We set the moves to 0 in here. Honestly, I don't care. It's already set to 0, so selected square, it's not used. And what else you don't like? Promotion square, it's not used. So it should be able to compile now. Nice, interesting. So if I run the game something like this, right, we need to use lib human, this lib human. It failed. Nice. Why did it fail though? So it's not something to do with this. Clearly, we would get some printf. This main help. Shit, it's the subcommand. We need to pass a game. Undefined symbol, the string slice token. Okay, interesting. So, shit. Why does it need this string slice token? Well, I think it needs, so it does move player 1, move player 2. Inside of init, we have this chess init fan, which is chess init fan. So which function? ds string slice token. Where is it used? It's used inside of chess.c in this init fan function. Okay, interesting. So if we check human.c, it depends on chess.h. Okay, so maybe we need to just add ds.o as a dependency here. Clean, make. See again. Shit, playing without the king SMH. I think else really failed. Just let's see. Really? Playing without a king. But doesn't it initialize the game though? Let's just not do anything here. So at least we know that it's kind of fine. Chess, let's see, where is this function called? Chess is in check. So it's called in chess valid moves. It's called in chess print board. Yeah, that makes sense. Chess count positions, that's not used. Is checkmate. Let's do something like this, login for tick. So we'll display the tick. So it's on the first tick. But it's weird if it's on the first tick. Okay, let's not check for checkmate. Let's not check for checkmates. Let's just ignore it. And let's see if at least we can move pieces. We cannot even move pieces. That sucks. Ah, because I haven't defined current player. So in when we initialize the pen, we have to say something like state current player is equal to chess white. To do hard coded to white. Yeah, I mean, no, it's kind of hard coded, but okay. So we can still play the game, but now we load the player from an SO file. So that way you can kind of customize the players. Okay, let's make some random moves so that we can. Oh shit. So promote didn't really work. Okay, let's see. Why didn't promote work? Chess print promotion. Let's try to remove some stuff, maybe. So that's fine. It means that load texture or something like that failed. Let's check if drawing a texture failed or maybe something else. Okay, so loading the texture, load the texture cached. It made it die. I mean, we have textures defined as a global variable, maybe that's why. So maybe we want load texture cached to get a reference to textures instead. Maybe we want it to work like this. Hash map textures. And here we can do that. Here we can do that. And now we'll have here textures. And maybe inside of game.h, I'm gonna put that there. So now we have this kind of global variable like textures, and kind of need this as well in human.c. Can I maybe just define it as extern or something? Extern. Would this make sense? Have it as some kind of external variable. It's funny how we have this. Nope. Okay, so human. Let's have it textures too. I mean, it's not even initialized. That could be a problem. Well, obviously we could have something like init plugin and so on, but let's just load texture without caching in this one. Right, let's just load the texture and pretend that we don't really care. So let's see, will this work? Yeah, kind of. So obviously we would like to have some kind of init plugin so that we don't load this thing like that. So maybe let's try to have that, void chess init or something like that. So this chess init function is gonna be called when we first launch the game. Now the question is, how is this one going to look like? Not sure. Init t. So we'll have something like extern void init player 1 and init player 2. These are going to be the functions. I have to let's say fn, so it's like the reference init t init player to fn. Kind of annoying, but it's fine. Okay, so then inside of here, let's go this one fn, and this should be moved like with lowercase. Okay, init player 1, like init player 1 fn, init player 2 is init player 2 fn. Okay, and we have to define this. I mean, we don't need a reference to them because we just call them, but let's say init player 1 fn, init player 2 fn, because we might have something inside of these functions. Okay, let's just call, oops, just call them like this. Okay. I mean, it didn't really matter though, honestly. So if we go to game.h, maybe I want to rename these ones to have the fn in name so that they are similar to the arguments. Yes. Right, when we pass them here. Hopefully this is gonna be working. Okay. So if we go back to main.c, we can have init t init player 1, init player 2, init player 1 is init t, DL symbol, strat1, chess init, and then we have to do the same for player 2. Okay, so now if we go to human, we have this chess init function, and we can load cached textures. Now, game.c. Yeah, it's like going to complain, I guess, here because we do that, but it is what it is. We kind of need these. So we need max capacity. Let's put it into game.h for now. And allocator. Okay, that's fair. Maybe chess init needs the allocator. But obviously we want these string hash and string maybe we want to have them in something separate as well. but the allocator is going to be interesting. So yeah, I think we want to pass in the allocator in here. How can we do that? Can I just easily say allocator like this? And it's gonna be fine. Looks like, yeah, I can. Nice. Human, so allocator. Oh, multiple definition of init player one. So it's inside of game. So game.o. I see. Game.c. So we have this init player one. Can I define them as static somehow? Like if I have static variables. Oh, nice. They are not conflicting. Nice. That's. Wait, why don't I do this everywhere then? Because I don't want to access them from different places anyways. I just want to have some global variables and have them as static. So if I run this thing, I should start with a different position so that we get so it loads it once. That's perfect. And if I do that, what? Let me just go here and I'll change this one with the P, capital P. So now if I, so it can do that. Nice. So let's see if we can actually checkmate our opponent. We can also checkmate him. Nice. And cannot move anything. That's perfect. Okay, that's pretty decent, I would say. So if we change this thing back and we go to game.c, have all of this crap. I would say that do we need to change anything? Oh yeah. So in the init function, we pass these things, right? So what I want to do with human.c file is compile it to WASM. So let's go to Webpack. And I'm gonna compile it to WASM like this, right? So I need human.c and we'll compile it to human.wasm. I think we also need game.c though. But on top of that we need human. Like I'm gonna try to make it smaller dependencies, like not depend on each other that much, but let's see if this is gonna work. So npm run build. It doesn't compile obviously. Wait, what? I guess. But where is that? Line 62. So it says that textures is, I mean, it is a pointer. So why did it work before? Fuck knows. Now it compiled. Nice, interesting. Let's next develop. Let's go to dist, and we still need to do something. So the init function takes init1 as a number, I mean, yeah, they are numbers. Move one number, move two number. Okay, interesting. So the init function actually needs more stuff. Where is it? It's here. Interesting. Can I maybe fetch multiple things? Let's maybe have something like const env. Is equal to something like this. Maybe. But how can I now load the other WASM module? So interesting. Maybe I need to do something like const memory is equal to this, and then can I just use it here? And then instead of doing this stuff, just reuse that variable. I don't know. I'm not sure. Because the second, if you think about it, let's see, this one kind of uses the other allocator, so it uses the other's instance memory. I mean, let's leave it like this for now. Let's leave it like this. And what if I do something like inside of then we do WebAssembly instantiate streaming, fetch human.wasm, and then inside of the env we use the same env somehow, and then we do then, wait, what the fuck am I doing? Then value, I mean, it's like human. Okay, right, so I do this one at the end. Shit, let's think. So we want this, oh, I'd say I put that there. I take the init function, memory, and then we call to init in here. We cannot do something else. Let's do that. Fuck. to catch the other error. I think that's that, or something like this anyways. Okay, and here let init one is human dot instance dot exports dot chess init as number. Right, then init 2, then we need move 1, then we need move 2, and these ones are something like chess move. So here we have init 1, 2, move 1, move 2. Is that going to work? I mean, whatever, any. Ah, fucking no. Let's run build. Let's HTTP serve this bitch and localhost 6969. As expected, it doesn't work. Indirect call to null. Let us see what this thing contains. Let's actually see human as an instance. I'm curious. It's an object, instance, exports. What's that? Oops. Let's see what if chess init is actually something. It's a function. Length 1, name 15. So it is doing something. But it's a function. That's the curious part. It's a function. And maybe it doesn't make sense to call it like this, like having a pointer to a function maybe. Game, let's see. So again, what I was thinking is maybe init should work like this with C, and with WASM we define the extern functions. So as I did in game.h, in here I defined them as external. So maybe we want to do something like this. So then the init function should be something like if def wasm, we do something else, we do this, and here we actually don't have these ones. I guess, I can keep it like this actually. And what I can do instead is these functions are defined as external, right? And in the C code, I'm gonna define them as wrappers around my pointer thingies. And in WASM, it's gonna be something similar. So let's keep them as they are here. Okay. And then if we go into game.c, we just call them as it is, or as they are, actually. We don't even need these things. then. So this is fn, oops, this is fn. And here it should be ds allocator. Okay, and here we use fn as well. So yeah. Now if we go to main, it's gonna say, oh, you don't have those, sure buddy. And in here we have to define them. So if we go back to game.h, let's copy paste these things, and I'm just gonna do init player1 allocator. Let me also maybe just do return just in case. I'm gonna change it, and I'll forget to, although I mean, even if I forget, cannot return move player1 to board and return move player 2 off board. Nice. So that's how I think it should work. If I run make, it should still compile, it should still work. Oh, undefined symbol. So inside of human, undefined symbol init player 2 fn. What? Let's make it clean. Let's make undefined symbol init player 2 fn. Init player 2 fn. So I guess that's a bit annoying. For now, let's just add main.o as a dependency, even though, yeah, again, I will see, make clean. Like, yeah, I have to clean it up a bit because right now it's really annoying. Oh, it doesn't show me the check. I have to think about that. Now it showed it. Whatever, doesn't matter. It's just it doesn't have a reference to those functions, so yeah, I have to link with main.o. It's not ideal. I'm gonna handle those things on my own, but for now, it's like building the proof of concept, seeing that it works, and then I clean it up. Okay, perfect. So now we have these kind of functions, right? And in the C world, they have to be defined, and in the WASM world, they'll be defined in JavaScript. So if we go to index.ts, we get these things, right? We get these functions from the human instance. So shit, does that mean that I have to load first the human instance and then the... I guess it does, doesn't it? So let's move this one first, the human instance. Right, and then we load the main instance. Okay, let's put it here. Let's call this one value and this one human, for instance. And let's copy paste these things outside. So the idea is we first load the SO file. We have to take these functions. We'll see what we do with them. We have the env, right, with the memory and stuff. Put w value. We set the init function. Take this memory. I don't know why we need this. Oh, for the init. Yeah, of course, for the init. Okay, init, then the init function doesn't need these things anymore. All right, but we need to add these functions into the env. So let's have something like init player function. It wants an allocator, which is a number, and returns void. And then we have the move player function, which takes in the state, which is a pointer, and returns void. But that's not really important. Init player function, move player function. No, these are not that important, that we cast them to the right values. What's more important, I think you can use pipe to add more things. You can't. The fuck? JavaScript merge objects. How can I merge two objects? Sign. Object assign. What can I merge two objects? Yeah, oh, with 3 dots. Okay, so then we need the following kind of function. So let me just copy paste one of them just to have it. So we need to do something like this, and we need to add these external ones. So the ones from game.h. Init player one, it's gonna take the allocator as a number, returns void, and it just calls to init one allocate. Cannot I just I guess I don't really know. Let's see if this thing is gonna work. So then we need move player one is gonna be just move one, and it takes the state, and move player two, which should take the state as well. So let's npm run build, and if we refresh this one, import object failed, is not a function. What? It's pretty cool. That's because does this thing need the defines as well? Is it stupid? I mean, I guess it does, right? Maybe it makes sense. Let's make them not do anything though. Fail to allocate hashmap buckets. Shit. Okay. The fuck? Human C. Chess move. Interesting or not? Let's do some console logs, I guess. So it goes into there. That's nice. So init player one function. I mean, it calls it though. That's interesting. So I thought I have some kind of console log. Yeah, I have a console log. Oh, it's also in ds.h. The fuck? Shit. Or is it ds log in? Yeah. The allocator is %d. Maybe I can cast it to an integer, or I guess I have to do long allocator and then cast it to an int. I'm curious to see. Oh shit, what? So it's just interesting. So maybe I want it to be a pointer. Yeah, am I stupid? It has to be a pointer. Here, inside of chess init. Otherwise, it's kind of retarded. Okay, anyway. So, chess init, I guess it needs to be a pointer. Make clean. Let's see where the error is. Okay, I guess for this, there's not really an error. Yeah. Okay, whatever. Alright, so inside of game.c, we call to init here, and we pass the allocator like that, but I think we need to pass a reference to that. So here I think it needs to be pointers. Right, and init t, I think it needs to be also pointer. And then in main.c we need, what am I doing? Inside of game.h we need this to be pointers. Like this, still it's fine, whatever. And then in npm run build, still failing to initialize, fail to allocate hash map buckets. Sure, what if I, don't do that, just to see what happens? Would it at least playing without a king SMH? Just init. Interesting. So I guess the problem is if I load this WASM file, it's I mean, it makes sense. Maybe it has a different memory than this one. Maybe that's the problem. But again, like I would have to make this human.c file such, like implement this thing such that it's, it's not doing it's not changing the state. Maybe it's just returning one move or something like that, and then I apply it in the game.c. So then this thing should be much simpler and it doesn't need to access memory from the other place. So maybe I have to refactor it in that way, but I think that's the main idea maybe, but I don't know if it's actually going to work. Loading this WASM file, then like at least we see that these functions are being called. At least that's what we see. And then we load the main one. So maybe something similar to this, but yeah, sadly it doesn't work as I expected. But I mean, at least, we got the SO files working. So I was thinking it's gonna be the same logic. But why isn't it? Like, sure, I could be able to do something like this maybe, and it's gonna run, but it still doesn't work. Because the idea is human.wasm already has the main.c file inside of it, so it should work. But yeah, kind of annoying. Like we could maybe do something lame like this. I'm curious if at least we can get it to, yeah, that's kind of annoying. So what would be, or what I would like to try, trying something else. I think the state it's fine like that. obviously like factoring things out from the game.h, but I think this idea with extern function, it's fine. I think that's fine. So we need an implementation for this thing. Like we request implementation for this thing at runtime basically with WASM. But maybe the init is not right. Maybe we need to implement it somehow differently. Okay, that's one of the things. Right. The other thing is maybe we want human.c file, like the plugin, to not depend on game. That's another thing. And also on main. What the fuck is that? So yeah, it doesn't make sense for the human or like any plugin to depend on game.h. That could be one of the problems. On ds.c, fine, like sure. But what would be the main issue here? Like what I think is the main issue. Human.wasm. We load our wasm file. Is this being called? Like I'm curious. That would be interesting to see. Not really. So as I expected, this one is not called, but yeah, it's like not going to work without defining these things, because we like human.wasm depends on game.h. That's one small issue. When does fail to allocate happen? So fail to allocate, it's in case the buckets are null. Okay. It's in case the buckets are null. Maybe we can console log allocator here just to see the value of the allocator. 2020. So it is something allocated like in memory. Okay, it's something in memory at least. But that happens somewhere here, which is annoying. But again, if I just ignore this, it still doesn't let me click on stuff. Like ds log info move. Like it still doesn't let me interact with the board. It says chess engine. What? It's like accessing a wrong memory somehow. Okay, let's try something else. Let's create new memory for each environment. I don't see what else I can do. If we try to use different memory for each one, and maybe env should be some kind of function, w, and w should be something from here. It should be a WebAssembly or null. Oops. What if we do something like this? So it should be WebAssembly or null, and it's a function that returns this. And it's, no, it's some kind of any or some shit. Okay, maybe parentheses. Okay, and any. And let's call this one make env. So make env, and here it wants w. And this should be like a different w then. Yeah. So let's w human. What if you say here w human, so it's a totally different w basically, and this is the main w. So here we get that, and here we say human, or something like this. And but see now, like, it's two different memories. That's the annoying part. Let's see if it's somehow working, at least. No, w is null. What the fuck? In which function? Yeah, but that's oh, it's because w, yeah. Okay, makes sense. Shit. Damn, that's annoying. It's because w, it's sent by like a copy and then it's being changed, so it's not so annoying. I don't know how to do that then, because it cannot be a function that takes w. And that's kind of annoying. Let's see, just with using different memories. So it's still printing like a random shit. Okay. Because I don't want to define this thing twice. That would be pretty annoying. Just for this. If it was a class, if I create like some kind of class, still don't know how to do that. It's annoying that it needs access to its own instance to get the memory. That's the annoying part. So yeah, I mean, I guess I have to try and figure out how to fix this stuff on my own, and then we can maybe try to do it together again. But yeah, I mean, at least we managed to make it work for DLLs, for Rayleigh basically. But I know I'd be interested to see how to do it for this as well. Like that would be interesting to see. Because then we can just define files like this, like human.c for instance, similar to this. I also want to think of a better interface for making moves, because updating the state in here, it's, you can cheat basically. So I want to think of a better way to do that. And yeah, then maybe you can easily implement your own AI and then load it from the browser, like make two AIs beat each other, or fight each other. So yeah, that's I guess that would be the plan for next time. So until then, see you. Okay, so basically it's later the same day, and somehow magically managed to get it to work, although it was a bunch of coding. But as you can see, we are able to actually use the game in WASM. Honestly, I'm curious if it's gonna work. It's still working, which is pretty cool. Also by just doing stuff like this. Let's see if we can checkmate the king. Probably I have to do that. Let's say I do that. Oh, I mean, it's way too complicated. Okay, let's just kill it. Okay, so we also get checkmate, which is pretty cool. Nice. So what did I actually implement? Well, what I realized was that, and I guess I realized that as well earlier, was that here, these WASM modules don't share the memory the same way SO files or DLLs do. So each of these WASM modules would have its own memory. What that means is, or I guess what that means for us when we take a look at, let me just delete this line because it's useless. It was just for debug. Here we pass a pointer to state, right? And I said that maybe in the future I want to make it so that you cannot cheat, like you can modify the state as much as you want at this point with just move. But the idea is you get a pointer to state, right? And in the SO file, it makes sense because it's just a pointer in RAM and you can access it. But in WASM, since it's different, you can think of it as the memory being three different arrays. One is for the main game, one is for the first player, and one is for the second player. And what happens is this pointer is a pointer in the main memory. And when we try to access it from human.wasm, from the first player's perspective, well, its own memory doesn't contain the data from the main memory, so we have to copy it. And I guess the easiest way to see how that works is in this function move player one, so it's the implementation for the external function. What I'm doing is I'm copying the structure from the WASM memory into the player one memory, then I'm calling the function, and then I'm copying the data back to the main memory. So I guess it's kind of interesting to also look at this and imagine that it's, I don't know, sharing data between two computers, like something like that. But yeah, and you can see here I'm using 0. It's like, I think it showcases better that we copy data from the main memory in some different place, and that's like the start, right? I mean, I guess it was kind of annoying to implement, but yeah, nonetheless it worked somehow. And yeah, I mean, the rest of the code stayed pretty much the same. I just copy pasted it in a different place so that we can have functions like this, like in classes. But yeah, the idea is it kind of stayed the same. Except this part right here, which, yeah, it's kind of annoying. But it is what it is. I don't think it's possible to do it in a different way. So yeah. And, you know, the final step would be to get these two strings from the query parameters, but no idea how I can do that. Maybe we can just leave Copilot try to do it. From query params. Let's see. Okay, let's see. Okay. So I guess at this point it's gonna, I mean, sure, why not player 1 WASM and player 2 was, at this point we only have the human players, but maybe, you know, in the future we might be able to get, so what is it like, player 1, so it's like player 1 human.wasm and player 2 is human.wasm, so something like this. But and let's say we don't even add wasm, we do plus wasm at the end, right? So like you just provide it with the name of the thingy. So you can see it works because it crashed, so I have to recompile it. So yeah, player 1 is human, player 2 is human, and you can actually play the game, which is kind of fun that you're able to do that. So yeah, I guess now we actually got something that works. It's kind of cool. I mean, obviously there are still some bugs in the code, like you saw that the images are not sized properly, maybe that's something, but I think it's kind of a cool concept. I'm curious now if the other one works. So LD, and the Raylib version still works. So I think that's kind of cool that we are able to have two implementations basically from scratch that work both natively and in the browser. So I think, yeah, I guess that's pretty cool. And that's not really winning. So is that winning? Yeah, I guess it is maybe one. So yeah, I guess that's kind of it for today. In the end, we managed to get it to work, which is pretty cool. So, you know, obviously here we might want to have something like human, random player, and good AI. But first, I think I want to change this function to work, to have some kind of different interface. And then maybe I can figure out, like, sure, implementing a random player just for fun to have a different thing here besides just human. I think that's pretty cool. And then the AI player. So yeah. And obviously I might add in here like a drop down, or I don't know. It's like that part comes in the index.ts for like in the HTML part. So yeah, different than the Raylib version. So yeah, hopefully you found this useful, and let's see in the next one. So until then, see you.